All right, for this video, we're going to be in lesson 5-6 for us in Algebra 1. That's taking us into graphing inequalities in two variables. So essentially what that means, as opposed to what we've done in the past with visually representing our data on a number line, now we're going to be in a coordinate plane. So we have not only like an x-axis, we're going to have a y-axis as well. So something like what we have shown here, even if we have a more simple example to start where we only show one variable, the visual representation is still going to be in two variables. So let's talk about how we would go through something like this. And to do that, we'll show the T.3 IXL. So that's actually going to be one of the things that we'll have assigned in class for us. So this will kind of act as a way of explaining that too. Okay, the first one just says to graph this inequality, but then it also mentions plotting points on the boundary line, and then it kind of tells us how we do that. So let's graph this. When we have just a single variable, if that variable is a y, we're going to go to whatever y value they specify. In this case, it's -5. And we're going to start to plot our line at -5. So from 0, I would go down to the y value of -5. I'm going to put a point. Anywhere else to keep this a horizontal line, I would plot another point. Doesn't matter where as long as it's horizontal, because all y values on this line would then be -5. From here, we can click in between our points to go back and forth between a solid or a dotted line. In this case, because we have this line underneath that or equal to part, we're going to keep a solid line, meaning that values that fall on the line itself are answers for this inequality. And then we also want to shade either above or below the line. We're going to read from our variable, so we want numbers, so y values, less than or equal to -5. Because it's less than or equal to, I'm going to go below my line, which would be down here. When I click, it shows the shaded region. So I'm going to hit submit. Awesome. Okay, we'll go ahead and hit this one as well. This time our single variable that is shown is an x. So I'm going to go to the x value of -3. So I'm on the x-axis now, and I'm going to go to -3, plot a point. Anywhere up or down from that point to keep it a vertical line is okay, because all of the x values that fall on this line now are all -3. I have the line underneath that tells me or equal to, so I'm going to keep this a solid line. If I didn't have that, I would go dotted. Now I want numbers greater than or equal to -3. Typically, I would think of that as above my line. Because this is vertical, there's no above the line, it's left or right. So greater than is going to be on the right. Those are bigger x values. So I'm going to click on the right side of that line and hit submit. Okay. Let's skip ahead until we get something that looks a little bit closer to slope-intercept form. Okay, maybe something like this. The last one was similar that I skipped past. It just would have had a b value of 0. For this one, though, I'm going to graph it as if it's slope-intercept form. So that tells me my intercept is going to be at -6, meaning I'm going to start down at the y value of -6 and plot a point. From there, this slope in front of the x is technically a -1. So from that purple point I just made, because it's a -1, I'm going to go down 1 before I go to the right one, plot that point. Because there's no line underneath, I need a dotted line here, so I'm going to click on the line to change it to dotted. What that means, just to kind of reconfirm, if I wanted to pick out a coordinate that was on the line itself, it actually would not satisfy this inequality if I plugged in its x and y values. For example, this point right here, 0, -6, if I plugged in 0 and -6, it would not work out. I also want values that are less than, and then the rest of our inequality, because it's less than, I'm going to go underneath here. Sometimes when the slope is steeper and steeper, it's a little hard to tell where I'm above or where I'm below, I would say just think about the really extreme values, like all the way up top, all the way down below. We would get smaller numbers in this section. All right, real quick to kind of explain what I meant about plugging in like this point here of 0, -6. If I actually plugged that in, so I'm going to rewrite here. And if I actually plugged in a point that was on the line, it shouldn't work because it's going to be dotted. So let's try that. The y value is -6 less than -0. That's not really going to do anything. And then -6. -0 basically goes away. So I'm going to end up with -6 is less than -6. We know that is not true, so that's why it doesn't work. Something else that we can do, what this shaded region actually tells us, any coordinate I pulled out of here that falls in the shaded region would work when we plug in its x and y values. Any coordinate out here would not work. So let's pick something real quick. Let's do -8, -1. So like right here where I put the blue. -8, -1. So when I plug that in, I'm going to have -1 less than negative -8. So that's going to flip. And then -6. I'm going to go ahead and make that flip to 8 minus, oops, I was jumping ahead there. 8 minus 6. I'm going to get -1 less than, this is going to work out to be 2. That is true. Awesome, we shaded the right side. If I did something and I got it the other way around and it said it wasn't true, I would know I shaded the wrong side. Okay, let's submit. Let's see if we need to do anything else here. Okay, we can handle slope-intercept form now. Okay, it looks like this is about the extent of where we're going to get for this IXL, is that we're going to have to be able to graph slope-intercept form even if we don't start in slope-intercept form. So what that means is you'll need to solve. So I would take away 5x on both sides. I know I'm kind of writing on top of the instructions here, but what that would leave me with is just y on the left-hand side greater than. Now I'd have that -5x I just took away and a +5 that was already over there. When I go to graph this, I would start up at 5 because of that +5 at the end. My slope was a -5, so I would go down 5 before I go to the right one. I need a dotted line here because there's no line underneath. And then I want values that are above the line. So even though it's steep, I would reach like infinity on this side, and negative infinity would be on the other side. So I'd shade over here and submit. Good work. Awesome. Okay, do we have anything else? Not till we get into the 80s. Okay, same idea. You'd solve for y. All right, so we'll wrap up here. Hopefully this helped. Feel free to leave comments if there's something that didn't make sense, and definitely like and subscribe if it did help you. See you guys.